What if the Earth itself tried to tell us something? In the span of just 48 hours, satellites recorded a surge in solar activity. A geomagnetic pulse raced through the poles, and deep below, the planet's own electromagnetic heartbeat shifted. Then, as the interstellar object 3I Atlas crossed the exact heliocentric longitude aligned with Earth's magnetic footprint, Schumann resonance monitors around the globe spiked in eerie synchrony. Was it mere coincidence, or an interplanetary interaction science can't yet explain? Investigators traced correlations between the anomaly, strange auroral flickers, and faint electromagnetic echoes that made Earth literally ring like a bell. To skeptics, it's noise. To others, it's a pattern, an unseen resonance between worlds. Stay with us until the end as we unravel this mystery through data, timing, and impossible coincidences that may reveal something deeper about how the cosmos and our planet truly connect. The trigger event, when the planet rang. It began with a tone so faint that only the Earth could hear it. On a quiet night, as space weather monitors recorded nothing out of the ordinary, the planet's own electromagnetic cavity began to hum. Schumann resonance monitors, usually tasked with tracking the low, rhythmic pulses generated by global lightning, registered an unprecedented harmonic swell. Across multiple stations from Tomsk to Boulder, identical spikes appeared as though Earth's frequency had been struck by an invisible hand at the same moment. Far beyond the Moon's orbit, an interstellar visitor named 3I Atlas crossed the heliocentric longitude of 180 dig. To astronomers, this was a routine waypoint in its trajectory through the solar system. But to those monitoring Earth's electromagnetic field, the timing was almost supernatural. The resonance spikes aligned within seconds of the object's crossing, a cosmic and terrestrial synchrony too precise to ignore. At first, the anomaly passed unnoticed outside scientific circles. No earthquake, no solar storm, no lightning surge to explain it. Just a global frequency anomaly, subtle, pure, and perfectly timed. Researchers assumed it was a calibration error, a blip of interference, until data from Japan's ALF array confirmed it wasn't local. It was everywhere. A quiet wave of unease began to ripple through the scientific community. The Schumann resonances, those faint electromagnetic whispers between the ground and the ionosphere, had always been stable, a delicate set of harmonics defined by the size of our planet. For them to shift meant that something had altered Earth's electromagnetic environment itself. But what? Some suspected a geomagnetic storm, but solar observatories reported calm solar wind and steady flux. Others wondered if powerful lightning clusters could synchronize globally, but the data showed no atmospheric correlation. Then someone noticed the timestamp alignment with 3I Atlas. It was a coincidence that looked engineered. At the very moment the interstellar object crossed the invisible magnetic longitude that mirrors Earth's field line orientation, the planet's cavity resonance surged. The coincidence was so mathematically tight that even skeptics hesitated. In the following hours, sensitive instruments across Europe and South America continued recording low-frequency oscillations, a slow, decaying ring that faded over nearly 12 hours. To some, it resembled a bell after being struck. To others, a planetary response to a passing force. What's unsettling is that this wasn't the first time Earth had rung. Historical data from 1859, during the Carrington event, and again in 1958, during a magnetic superstorm, hinted at similar signatures, brief harmonic distortions in the ELF range that vanished without explanation. But this time there was no storm. The space around Earth was quiet. In the control room of a Schumann station in Poland, technicians replayed the raw data. The resonance harmonics didn't just rise, they doubled, briefly locking into a frequency pattern rarely observed outside artificial systems. It looked, in the analyst's words, like the Earth was being tuned. But tuned by what? Interstellar objects like 3I Atlas are supposed to be indifferent drifters, chunks of rock and ice wandering through the void. Yet 3I Atlas had already defied expectations. Its trajectory was steeper than predicted, its light curve inconsistent, its tail displaying plasma behavior unusual for its composition. When it crossed Earth's magnetic footprint, its proximity to the heliospheric current sheet suggested it was moving through a region of intense electromagnetic flux. If its ionized coma interacted even subtly with the Sun's magnetic field lines connected to Earth, the resulting perturbation could theoretically ripple through the planet's cavity. That's the conservative explanation. But the timing still felt orchestrated. In online research communities, speculation grew. Was the interstellar object carrying a magnetic field of its own? Could it be inducing current as it moved through the heliospheric plasma, like a conductor slicing through invisible wires? And if so, could that current, transmitted across the solar magnetic web, resonate with Earth's own magnetic shell? Some physicists dismiss the idea outright. Energy transmission across that distance would require coherence on a cosmic scale, a precision nature rarely demonstrates. Yet, the data refused to go away. The spike was real, recorded, peer-confirmed, and it happened when no known force should have caused it. A few voices within the geophysics community quietly floated an alternative hypothesis: magnetic resonance coupling. They proposed that 3I Atlas, while passing through the Sun's equatorial field, momentarily synchronized with Earth's magnetospheric flux lines. Like two pendulums aligning through resonance, the passing object could have pinged the Earth, not through direct energy but through alignment. If true, it would mean interstellar objects could trigger global electromagnetic responses simply by crossing key spatial geometries, and the possibility was deeply unsettling because if the Earth could respond this way once, how many other times had it happened, undetected, or misattributed to storms and seismic events? NASA quietly archived several magnetometer readings from the same period, labeling them instrument overlap. But leaked screenshots from an internal forum showed identical harmonic traces in their raw feed. ESA's instruments caught it too, though their official summary excluded those hours entirely. Coincidence or coordinated omission? Independent analysts reconstructed the timeline. On the same day as the resonance spike, faint auroral emissions appeared over regions not typically affected by geomagnetic activity: Morocco, northern India, and even parts of Central America. The skies shimmered green for minutes, unseen by most, but captured by satellite imaging. And then nothing. It was as if the Earth exhaled. The event faded, leaving behind a record of impossible synchronicity, a planet ringing, an interstellar traveler passing, and a silence afterward that felt almost intentional. In the days that followed, speculation evolved into inquiry. If 3I Atlas could trigger such a response, it implied that planetary magnetic fields aren't isolated systems. They are part of a connected lattice that responds to cosmic intrusions. The Sun, the planets, even passing interstellar debris, perhaps all locked in a faint electromagnetic choreography. What frightened researchers wasn't just the event itself, but its elegance. No explosions, no violence, just a resonance, as if the universe whispered through the Earth's electromagnetic skin. Yet deeper analysis revealed something stranger still. The frequency spike didn't occur in random bands. It aligned precisely with 7.83 Hz, the fundamental Schumann mode often associated with the planet's natural EM heartbeat. It was as though the pulse wasn't random. It struck exactly where it would be most noticed by the Earth's electromagnetic self. Those who study geomagnetic resonance describe it as the planet's voice. Some fringe theorists go further, calling it consciousness expressed as field vibration. The more rational explanation is simple physics, an electromagnetic cavity oscillating between the surface and ionosphere. But that doesn't make the timing any less haunting. Because 3I Atlas didn't just pass by, it crossed the exact longitude that magnetically mirrors Earth's field configuration at that moment in its orbit. If the event were coincidence, it would be an exquisite one. An interstellar traveler intersecting our planet's magnetic echo chamber just as that chamber began to sing. Even now, debates rage in private channels. Some researchers believe the event proves the existence of a larger heliomagnetic feedback system where interstellar magnetic signatures propagate through the solar medium, momentarily tuning planetary resonances. Others insist it was nothing but localized interference amplified by atmospheric conditions. But neither camp can explain why the resonance pattern decayed exactly like a Bell's aftershock, following a logarithmic fade consistent with acoustic damping, a pattern not seen before in electromagnetic records. The question remains, did something strike the Earth electromagnetically, or did Earth respond to a cosmic cue on its own? Perhaps 3I Atlas didn't cause the resonance but simply coincided with it, a messenger passing through a chorus already beginning. Or perhaps it was the conductor aligning magnetospheres across millions of kilometers for one brief, perfect note. Whatever the case, for a moment, the planet rang, and in that sound, somewhere between science and mystery, humanity was reminded of how connected the universe truly is. First observations. Data that shouldn't sync. When the first Schumann resonance spikes were logged, scientists assumed it was a regional anomaly, atmospheric noise perhaps, lightning storms flickering over the tropics or instrument drift caused by humidity. But when synchronized data arrived from observatories half a world apart, the pattern grew impossible to ignore. At precisely 2:17 UTC, monitoring stations in Tomsk, Boulder, São Paulo, and Nagoya all recorded identical harmonic distortions. Not similar, identical. Each displayed a sudden amplification of the fundamental 7.83 Hz frequency, followed by a split into subharmonic bands at 14, 20, and 26 Hz. The pattern was globally synchronous, down to the second, even more unsettling. At that exact minute, the interstellar object 3I Atlas had just crossed the heliocentric longitude, directly aligned with Earth's magnetic footprint. In ordinary circumstances, this would mean nothing. A coincidence between a rock drifting through space and a set of planetary radio pulses. But the timing was too elegant, too deliberate in its precision. To most it looked like noise. To a few it looked like resonance. In Japan, the Nagoya LF array registered amplitude spikes that mirrored the same mathematical ratios seen in Tomsk. The equipment wasn't even identical, different manufacturers, different calibrations, yet their traces overlapped perfectly, like separate instruments playing the same cosmic chord. Radio enthusiasts across Europe reported strange audio interference, a low, oscillating hum that modulated rhythmically, like a mechanical breathing, one operator said. In Germany, shortwave frequencies between 3 and 5 kHz experienced sweeping distortions, as if the ionosphere itself were resonating. Still, the mainstream explanation came quickly. Coincidental resonance, claimed the International Geophysical Union's first press note. Global thunderstorms could cause such alignment by sheer chance. Lightning discharges in the Congo Basin might sync harmonics worldwide. But that theory fell apart within a day. Global lightning networks like WWLN showed no increase in storm activity. The skies were relatively calm, unusually so for that week. There was nothing in the atmosphere that could explain the signal. Then came the magnetometer data. In Poland, the Belsk Geophysical Observatory reported faint, synchronized magnetic field oscillations around 8 Hz, the same range as the Schumann anomaly. Similar readings surfaced from an Antarctic base station, suggesting the magnetic fluctuations were not confined to one hemisphere. By the time NASA's AC satellite transmitted solar wind data, analysts were stunned. The interplanetary magnetic field had remained steady during the period. No solar flare, no coronal mass ejection, no external force. Yet the Earth had vibrated electromagnetically as if struck by an unseen pulse. The question that haunted researchers was not what caused it, but why everywhere at once. For years, Schumann resonances had been stable. Local shifts occurred, yes, but never in perfect global phase. For this event to synchronize across the planet, it would require a trigger acting simultaneously on every magnetic field line connected through Earth's ionosphere. And only one object had crossed that alignment window at that time. 3I Atlas. It was Dr. Pavel Sidorov, a plasma physicist in Novosibirsk, who first noticed the trajectory alignment. His late-night email to colleagues simply read, "We have a visitor," and the Earth sang. The phrase stuck. Within hours, independent researchers were comparing heliocentric coordinates. As 3I Atlas moved through the heliospheric current sheet, its position mapped almost perfectly onto the Earth's magnetic meridian, an invisible geometry that tied the two through the Sun's sprawling electromagnetic lattice. To skeptics, it was numerology, but to scientists familiar with plasma coupling, the coincidence was unnerving. Earth's magnetic field isn't isolated. It's an open system, part of a vast web that connects every planetary magnetosphere to the Sun's dynamic plasma flow. When interstellar objects like 3I Atlas cross these current sheets, they can, in theory, generate electromagnetic wake waves, disturbances that ripple outward through the solar wind. If timed precisely, one of those ripples could intersect Earth's field lines, producing subtle resonance amplification, and yet the coherence of the signal defied even that. If it were a solar or heliospheric effect, one would expect gradual onset, attenuation, and delay between hemispheres. But the Earth's magnetic and atmospheric layers responded instantaneously. Some researchers quietly proposed a form of electromagnetic standing wave, an instant coupling between two resonant bodies sharing the same geometric alignment. In other words, 3I Atlas might have acted as a reflector, bouncing the solar magnetic field's oscillations back toward Earth in perfect phase. The result? A momentary amplification of our planet's natural frequency, like two tuning forks humming in unison across the void. NASA's official response was more restrained. The agency released a short bulletin citing unusual geomagnetic coherence patterns, but dismissed any link to interstellar activity. Still, not everyone within the organization agreed. Leaked excerpts from an internal JPL correspondence revealed concern over what was called resonant coupling potential. One scientist wrote, "We shouldn't rule out that transient plasma structures can carry coherent frequency bands across heliocentric distances. The geometry this week is suspiciously perfect." Meanwhile, amateur researchers on social media began connecting dots. A small geomagnetic storm over Canada appeared hours later, weak but oddly structured. Seismographs in Finland and Alaska detected faint micro-tremors without tectonic cause, and high-frequency communication networks in South America briefly reported unexplained signal phase shifts, as if the ionosphere had momentarily thickened. These disparate clues pointed to one unsettling possibility. The anomaly was global, coherent, and energy-based. Something had transmitted through the Earth, not just across it. In the following days, observatories rechecked their calibration. Nothing was wrong. Even instruments sealed underground had caught the pulse. That meant the disturbance wasn't atmospheric. It penetrated the planet's electromagnetic skeleton. The timing continued to haunt them. 3I Atlas's crossing of 180-degree heliocentric longitude occurred at 02:17 UTC, the exact minute of the resonance spike. Not 5 minutes before, not 5 minutes after. Some began asking a forbidden question. Could the interstellar object have generated the resonance intentionally? The phrasing was rhetorical, of course. No one seriously believed a chunk of rock could act with intent. But the eerie precision sparked theories that went beyond physics. A few invoked ancient myths about stars that sing and planets that answer celestial visitors. Others turned to hard data, tracing a pattern of prior interstellar passings that correlated faintly with recorded Schumann fluctuations. In late-night calls between researchers, one phrase recurred: the data shouldn't sync. And yet, it did. By week's end, independent teams from Japan, France, and Canada had verified the harmonic match across 6 continents. The global phase coherence reached 0.98, near perfect synchronization. Even the most skeptical scientists admitted the probability of random alignment was infinitesimal if the Schumann resonance truly acted as Earth's heartbeat. Then something had tapped it in unison across the globe, but no known mechanism could explain such precision. ESA's Space Weather Division quietly began modeling plasma interactions between 3I Atlas's ion tail and the heliospheric field. The results were inconclusive but provocative. Simulation suggested that if the object's coma carried sufficient charge density, it could modulate the ambient solar wind. In theory, this modulation might resonate with planetary magnetic fields positioned along the same heliocentric longitude. Still, that hypothesis depended on an improbable degree of coherence. An interstellar object would have to align almost exactly with the Sun-Earth magnetic axis. Yet that's precisely what had happened. At a closed symposium weeks later, a quiet consensus formed. This wasn't coincidence. Something about 3I Atlas's plasma structure, or perhaps its velocity vector, had matched conditions necessary for transient coupling. One researcher described it as a bell struck not by force, but by geometry. As the data accumulated, a deeper layer of mystery emerged. For 12 hours following the main spike, global temperature sensors in the ionosphere recorded a subtle 0.3 degree Celsius rise, a negligible number on its own, but suspiciously uniform. This suggested electromagnetic energy had been absorbed and re-radiated across atmospheric layers, as though the Earth's shell had momentarily sung and then cooled. It's a poetic image, but in scientific terms it means energy transfer on a planetary scale. The anomaly eventually faded, leaving a trail of clean data that looked almost deliberate, one sharp global pulse, followed by a decaying resonance curve mathematically identical to acoustic damping in metallic bells. As the days passed, skepticism turned to silence. No one could explain how readings from independent, unconnected observatories matched perfectly. They weren't even synced by the same network clocks, yet the timestamps aligned within 1 second of each other. It was as if the Earth itself had served as the synchronizing mechanism. When questioned, one veteran geophysicist summed it up quietly. We see the fingerprints of an orchestrated event, but the conductor is missing. Whether it was plasma coupling, solar interference, or something the instruments were never designed to measure, one truth remained: data that shouldn't sync had synced flawlessly. And somewhere, far beyond the magnetosphere, the faint tail of 3I Atlas continued drifting away, silent now. Yet the memory of that harmonic note lingered in the planet's electromagnetic fabric, like the echo of a bell long after it has been struck. The anomaly deepens, discrepancies in the record. At first, the data looked clean, too clean. Every observatory's log aligned perfectly like clockwork. But when researchers began layering datasets, something strange surfaced. Timestamps that should have been identical began to drift, in some cases by only milliseconds, in others by entire minutes. The deeper analysts dug, the more the record seemed to fracture. It started with the NOAA Schumann monitor in Boulder, Colorado. Their instrument logs placed the frequency spike at 02:17:03 UTC, the precise moment 3I Atlas crossed heliocentric longitude 180°. But Japan's Nagoya station showed the same amplitude peak at 02:16:45 UTC and Poland's Belsk Observatory at 02:17:58 UTC. These discrepancies might have seemed trivial, except every one of those systems used atomic clock synchronization. There should have been no variation. Then came the missing data. When independent analysts tried to reconstruct the continuous signal from public archives, they discovered micro-gaps, fractions of a second missing at irregular intervals. Some were too short to matter. Others were large enough to break waveform continuity. In the raw data sets, entire minutes appeared as blank lines, annotated only with calibration pause or data redundancy buffer. But no calibration was scheduled. That night, it was as though someone or something had silenced specific fragments of the Earth's electromagnetic voice. In Cambridge, a small research collective compared NOAA, ESA, and private magnetometer data. The anomaly pattern was coherent across all datasets except one, the GOES-16 satellite's magnetometer, which showed no spike at all. Instead, it displayed a smooth line where every other sensor showed a violent jump. When they overlaid the readings, it looked like GOES-16 had been scrubbed or filtered to hide the spike. The timing mismatch deepened suspicion. GOES-16 system clock ran 3 seconds ahead of the Schumann monitors, yet the absence of data wasn't delayed, it was anticipatory, as if the satellite had stopped recording before the event occurred. At the same time, European Space Agency archives quietly revised several data files from the same period, changing timestamps and smoothing signal irregularities. When a user compared backups downloaded a week earlier to the new public versions, the differences were obvious. Where there had been jagged peaks, there were now gentle slopes. Where the harmonic distortions had once been sharp, they were softened into noise. The official explanation: signal resampling for uniform visualization. But the effect was unmistakable. The anomaly had been erased from the record, at least the public record. A physicist in Novosibirsk, Dr. Pavel Sidorov, the same man who coined the phrase "the Earth sang," noticed a deeper problem. The frequency ratios from the surviving data didn't match any natural Schumann distribution. Instead of the standard 7.83, 14.1 and 20.3 Hz harmonics, the secondary and tertiary modes had shifted by precisely 0.27 Hz upward across multiple stations. The odds of such identical shifts occurring spontaneously were astronomical. Even stranger, the frequency shift aligned with theoretical predictions for plasma sheath interference, a phenomenon where ionized material distorts electromagnetic cavities. But no solar flare, CME, or lightning activity existed to justify such plasma density. So where did the distortion come from? Sidorov cross-referenced orbital data of 3I Atlas during the anomaly. The object's tail, though faint, was composed of charged particles, mostly sodium ions, moving through the heliospheric current sheet. If the object's plasma tail intersected one of the Sun's extended magnetic flux lines connecting to Earth, a transient current could theoretically propagate through that pathway, like a whisper traveling along a wire. That whisper, if resonant with Earth's field frequency, might have triggered the global harmonic shift. The idea was bold, borderline, heretical, but it fit the data. Then another inconsistency emerged. NASA's public database listed no recorded interplanetary magnetic field deviation during the event. Yet internal logs leaked from the AC satellite showed a 6 nanotesla spike at the same moment. The spike was minor, easily dismissed as noise, but its timing was perfect. Those few nanoteslas were enough to disrupt Earth's magnetospheric equilibrium, perhaps triggering the resonance bloom observed across Schumann monitors. Still, one question refused to die. Why were the data gaps and time drifts so precisely placed? Independent data analyst Marina Voss, who had previously worked on signal integrity at CERN, noted something chilling. The missing fragments in the global datasets didn't occur randomly. When plotted sequentially, the gap intervals formed a pattern. Every missing block aligned with a harmonic multiple of 783 Hz. It was as if the missing data itself followed the same rhythm as the resonance spike. Either the instruments were failing in synchrony or something had selectively filtered the data according to frequency. Meanwhile, university researchers in Kyoto and Zurich confirmed that their stations had temporarily gone offline during the spike. Network interruption, the log said. But packet analysis revealed the interruptions were hardware level, not network level. Their instruments had physically stopped transmitting. One theory emerged that made even the most skeptical scientists uneasy: a magnetospheric feedback pulse. The idea was that 3I Atlas's electromagnetic wake might have briefly coupled with the Sun-Earth magnetic circuit, creating a feedback loop that reflected back into the planet's ionospheric cavity. Such a loop could generate a transient standing wave strong enough to overload sensitive sensors. It would explain both the data loss and the harmonic precision, but it would also mean that Earth's electromagnetic system had momentarily gone nonlinear, reacting to an external input in a way no model could predict. If true, that would change how we understand planetary magnetism itself. By now, whispers were spreading through the community. Reddit forums, obscure Telegram groups, and encrypted physics chat rooms were abuzz with speculation. Some believed agencies were deliberately suppressing the data to prevent public panic. Others claimed this was proof of artificial modulation, that 3I Atlas was not a natural object, but an engineered probe, testing resonance coupling with planetary fields. Even professional researchers, normally cautious, admitted privately that the patterns were too structured to be pure coincidence. A few journalists tried to investigate, but hit walls of silence. Requests for the full resolution Schumann datasets from national institutes were either denied or returned incomplete. Freedom of information requests to NOAA came back redacted, citing proprietary sensor calibration information. The story began to resemble a cosmic detective case, evidence vanishing, timestamps shifting, and the trail of anomalies leading deeper into the machinery of the planet itself. One data set survived untouched, recorded by a private ELF station in Argentina, operated by amateur radio physicists. Their data showed the unfiltered spike in full resolution. It wasn't smooth. It wasn't random. It was structured, an amplitude envelope repeating in a pattern resembling binary modulation, on-off in consistent intervals. This discovery changed everything. If the global resonance carried an encoded pattern, it suggested not just energy transmission but information. Could an interstellar object, by passing through the heliospheric current sheet, modulate magnetic fields enough to imprint a message onto Earth's natural resonance frequencies? It sounded absurd. Yet that's what the waveform implied. The binary-like oscillation lasted exactly 3.6 seconds, long enough to encode hundreds of bits of information if interpreted as digital. Pulses most dismissed it as pareidolia, humans, finding meaning in randomness. But those who examined the full waveform noticed something that refused to be coincidence. The pulse intervals matched prime number spacing, 2, 3, 5, 7, 11, 13, not evenly distributed, but deliberately sequenced. One researcher simply called it a mathematical ghost. NASA's public stance remained unchanged. No evidence supports extraterrestrial interference or magnetic resonance coupling. Yet, within a month, the agency quietly updated the GOES data portal to include temporal smoothing filters on all high-frequency magnetometer feeds, making it impossible to detect similar events in real time. Meanwhile, the global academic community began to fracture. One side demanded transparency, accusing space agencies of quietly rewriting the event. The other warned that speculation could erode scientific credibility. But neither side could explain the missing minutes, the harmonic distortions, or the curious alignment of frequency shift intervals. Then, in late reanalysis, something new emerged. A graduate student in Chile compared the residual signal decay curve from multiple observatories and found a perfect match with a natural resonance damping equation, except the curve began before the initial spike. In other words, the Earth had started responding before the event occurred. How could that be? The leading hypothesis pointed to nonlinear field entanglement, that the coupling between Earth's magnetosphere and 3I Atlas's plasma trail began before physical alignment, due to long-range electromagnetic coherence. But the philosophical implications were staggering. It suggested the planet's field anticipated the resonance. The more the data was corrected, the less sense it made. Discrepancies multiplied, missing timestamps, altered calibration notes, frequency drifts that defied known error margins. What began as a clean scientific anomaly had mutated into a labyrinth of contradictions. The event's raw essence, what truly happened during those seconds, was now buried under revisions and silence. But one undeniable truth remained in the surviving independent datasets. For a fleeting moment, the planet's electromagnetic signature behaved as if tuned from the outside, shifted, synchronized, and then allowed to fall back into silence, and every attempt to clarify the record only deepened the mystery. Hidden connections, cosmic resonance, and terrestrial reactions. It began as a search for correlation, a way to make sense of numbers that shouldn't exist. What scientists discovered instead were fingerprints linking the anomaly to forces far beyond Earth. At first, the data seemed to belong to two separate worlds, one terrestrial, one cosmic. But as researchers overlaid datasets, a pattern began to emerge, faint, symmetrical, and impossible to dismiss. The Schumann resonance spikes that coincided with 3I Atlas were not isolated electromagnetic curiosities. They lined up with a chain of other events, faint auroral surges, fluctuations in ionospheric density, irregular magnetotail currents, and even slight shifts in ground-based seismic monitors. Each occurred within hours of the interstellar object crossing Earth's magnetic longitude. Individually, they could be dismissed as coincidences. Together, they formed what one astrophysicist called a magnetic echo of cosmic geometry. The first connection appeared in data from NASA's MAVEN, spacecraft orbiting Mars, just as 3I Atlas crossed heliocentric longitude 180. MAVEN recorded a transient spike in magnetospheric plasma density, a pulse echoing across a field line that would, in a matter of hours, connect to Earth's orbital sector. It was as if the same wave that brushed Mars continued onward, threading through space toward our planet. On Earth, that wave's arrival manifested as a harmonic pulse, the Schumann surge that made the planet ring like a bell. When the timing alignment was plotted on a heliocentric map, it revealed something extraordinary. 3I Atlas's trajectory intersected a region of the heliospheric current sheet precisely where it folded toward Earth's orbital plane, a region known for intense magnetic shearing and particle coupling. It was the same geometry through which interplanetary shocks can propagate almost instantly through the solar plasma. In simpler terms, 3I Atlas had flown through the Sun's magnetic highway, and Earth was downstream. Even more peculiar was how the effects cascaded across multiple planetary layers. While magnetometers at the surface recorded field oscillations, atmospheric sensors logged brief changes in electron content, and auroral detectors noted faint light emissions outside typical geomagnetic zones. For a few hours, the entire electromagnetic shell of Earth seemed to shimmer, pulsing in harmony with a distant traveler of interstellar origin. Skeptics insisted that correlation was not causation, yet the mathematical symmetry was undeniable. The delay between 3I Atlas's crossing and the first recorded resonance spike matched the estimated propagation time of a magnetic perturbation through the solar wind, 58 minutes, exactly the time it would take for an electromagnetic disturbance moving at average solar wind velocity to reach Earth's field. Coincidence or choreography? At the University of Helsinki, a team specializing in magnetospheric coupling ran simulations to test whether a passing plasma body could, in theory, generate a resonance wave along heliospheric lines. The results stunned even them. The model showed that a sufficiently charged tail, like that of 3I Atlas, could set up a temporary standing wave between the heliosphere's surface and planetary magnetic fields. This wave, though faint, could synchronize with Earth's natural Schumann modes, amplifying them dramatically before fading. In essence, 3I Atlas might have strummed the planet's magnetic strings. That metaphor spread quickly. Soon, science forums and research circles began using a new phrase, cosmic resonance coupling, a theoretical bridge between interstellar plasma, dynamics and planetary electromagnetic behavior. Next, connections surfaced in an unexpected place beneath the ground. Seismologists in Chile and Alaska independently reported low-frequency micro-tremors detected during the same window as the Schumann anomaly. The tremors were not tectonic, but electromagnetic-induced ground vibrations, the kind usually caused by geomagnetic storms. Yet, no storm had been recorded. It was as if Earth's crust had resonated in sympathy with its magnetic field, translating an invisible frequency into physical motion. Even biological systems seemed to react. Data from the Global Consciousness Project, a long-running network of random number generators used to detect global coherence, showed statistical deviations beginning an hour before the resonance spike and lasting nearly half a day. To some, this was meaningless noise. To others, it was a whisper from nature itself, the suggestion that the entire biosphere, including consciousness, might respond to electromagnetic harmony. As the investigation expanded, researchers noticed subtler parallels. Ocean buoys in the Pacific registered minute fluctuations in water temperature and pressure that mirrored the timing of the anomaly. Atmospheric researchers observed rare noctilucent cloud formations near the equator, far from the poles where such clouds normally appear. All of it hinted at some form of planetary coherence, a temporary tuning that extended from magnetosphere to ocean floor. What could connect these disparate systems? Some physicists turned to the concept of field resonance transfer, the idea that electromagnetic oscillations can synchronize across vastly different mediums if they share harmonic ratios. The Earth's cavity frequencies are not random. They are harmonically related to the scale of the planet itself. If an external driver, say 3I Atlas's charged wake, introduced a coherent oscillation matching one of those ratios, the entire system could, theoretically, vibrate in unison. It wouldn't take immense energy, only precision. That precision, in fact, appeared again and again in the data. Each secondary phenomenon, auroral flickers, ionospheric heating, seismic murmurs, peaked at intervals corresponding to multiples of 7.83 Hz, the fundamental Schumann frequency. It was as if every layer of Earth's system had momentarily locked into the same cosmic rhythm. This discovery raised profound questions. Could the Earth act as a resonant body within the heliosphere, sensitive to the electromagnetic music of passing celestial objects? If so, how many other times in history had the planet responded, unnoticed, to such cosmic alignments? Historians of science began digging into old data. Records from 1859 during the Carrington event showed faint anomalies in compass readings hours before the solar flare struck. Possible precursors. In 1972, when an unidentified comet passed near Earth's magnetic longitude, similar low-frequency pulses appeared in ionospheric logs. The pattern suggested a recurring phenomenon. hidden in plain sight, planetary resonance triggered by cosmic proximity, and then another pattern emerged, one buried deeper. The Schumann anomaly didn't just correspond to 3I Atlas's trajectory, it also aligned with an opposing node in the Sun's magnetic polarity, a reversal zone predicted by heliophysicists studying solar cycle 25. In that moment, the solar magnetic field was in flux, its current sheet warping dramatically. Earth's own field lines were already stretched, waiting like taut strings. Atlas passed directly through that turbulence, and the planet sang. Coincidence? Or was the interstellar object amplifying a process already in motion, the way a violin bow amplifies a string already vibrating near resonance? To some, this was evidence of natural harmony, the Sun, the Earth, and interstellar matter participating in an electromagnetic dialogue that spanned the solar system. To others, it was a sign of something stranger, a self-organizing system, a kind of cosmic feedback mechanism built into the fabric of reality. If such a system existed, the implications were staggering. It meant the universe wasn't merely a collection of isolated bodies, but an interconnected web of resonances, each capable of influencing the others through geometry and timing. For months after the event, anomalies continued to echo faintly in the data. Magnetometers recorded periodic micro-oscillations at frequencies slightly above the baseline, as if a residual pulse lingered. Some speculated this was the electromagnetic equivalent of aftershock, Earth's field still settling after a cosmic chord. An independent researcher in Germany discovered something even stranger. When the amplitude of the lingering oscillations was converted into spectral color equivalents, the peaks aligned with auroral wavelengths, greens, purples, and reds, the same colors observed in faint, unexplained glows during the anomaly night. It was as if the resonance had not only been electromagnetic, but also optical. The planet had literally shimmered in response. In late follow-ups, an internal ESA memorandum leaked. It stated, "The coherence across atmospheric and magnetic datasets suggests a linked system response, possibly driven by external plasma perturbation. The level of global symmetry cannot be explained by local causes." Though never officially acknowledged, the memo marked a shift in unspoken admission that the Earth's resonance might indeed be coupled to cosmic dynamics, and then came the most chilling detail of all, when scientists plotted the waveform of the globally resonance spike and compared it to the known plasma oscillations of 3I Atlas. They found an uncanny match. The frequency patterns, the rise, decay, and harmonic spacing, were identical. In essence, the planet's voice during the event echoed the signature of the passing interstellar object. Was it mimicry, reflection, or a kind of conversation between two magnetic entities passing in the cosmic dark? No one could say. Some theorists proposed that such resonance might be the mechanism through which information is exchanged across astronomical distances, not through light or radio, but through the synchronization of magnetic harmonics. If true, the event might represent not an accident, but communication, an ancient, natural language of fields and frequencies. Whatever the explanation, one truth remained. When 3I Atlas crossed Earth's magnetic footprint, the entire planet responded. From the ionosphere to the crust, from auroras to the oceans, and somewhere in that fleeting harmony, between measurable data and cosmic mystery, the boundaries between Earth and space blurred, as if, for a moment, the universe had reminded us that it was never separate at all. Suppressed or overlooked data, the silent revisions. In the weeks following the Schumann resonance anomaly, a strange silence settled over the scientific community. At first, the event had sparked excitement. emails, late-night Zoom calls, and public forum debates filled with hypotheses and raw data exchange. But then, as quietly as the resonance itself, those conversations began to vanish. Data sets once public became restricted, links expired. Archives were replaced with revised files that bore no trace of the original signals. To the casual observer, it looked like a natural cleanup effort, data validation, noise filtering, ordinary academic rigor. But to those who had seen the raw logs before they disappeared, it looked like something else entirely, a systematic redaction. The first hint came from a research assistant at the Tomsk State University LF monitoring station. He posted on a private forum that his team had been instructed to update their graphs with corrected amplitude scales, but the new graphs no longer showed the sharp peaks recorded during the 3I Atlas crossing. Instead, they displayed mild fluctuations, normal, unremarkable, and safe for publication. Within hours, his post was deleted. The same week, NOAA's Schumann resonance database went offline for maintenance. When it returned, data for a 24-hour period around the anomaly was missing, replaced with a note, incomplete telemetry, archived for internal review. Internal review. The phrase would repeat across institutions like a quiet mantra of containment. Researchers from Poland, Brazil and Japan privately compared old screenshots of their instrument logs with the newly uploaded files. The differences were subtle but consistent. The amplitude spikes had been smoothed. The timestamps slightly shifted, and in some cases, the frequency markers rounded off to the nearest tenth of a hertz. But when those same cleaned datasets were reanalyzed, the anomaly disappeared entirely. For those who had witnessed the raw data, this wasn't coincidence, it was revisionism. One anonymous ESA scientist leaked a memo dated just 2 days after the event. It read, "Due to potential misinterpretations and public misrepresentation of resonance data, it is advised to temporarily limit external access until the data sets have undergone harmonization and calibration checks. In other words, until they'd been rewritten to fit the narrative. And yet, beneath that layer of control, fragments of the original signal continued to surface. Independent researchers who had downloaded their own copies before the deletions began comparing them line by line. They found something remarkable: identical data corruption patterns in multiple institutions' revised logs. The same missing frequencies, the same flattened peaks. The odds of that happening naturally were astronomical. It was as if the world scientific agencies had coordinated to erase not only an anomaly, but the shape of its truth. One of the most disturbing discoveries came from an open-source data analyst in Germany named Jonas Richter, who specialized in electromagnetic mapping. He cross-referenced magnetic field data from the GOES-16 satellite, ESA's swarm constellation, and ground stations in Canada. His analysis revealed that all the revised datasets shared an identical digital watermark, a pattern of noise insertion at specific intervals, consistent with algorithmic smoothing. This wasn't cleaning, Richter wrote in a private post later deleted. It was suppression by automation. The real question was why. No one in the mainstream dared to ask publicly, but inside encrypted channels the possibilities spiraled. Some believed the agencies were covering for an internal error, an unacknowledged instrument malfunction that, if admitted, would undermine trust. Others suspected something larger, a fear of sparking panic over the idea that Earth's electromagnetic system could be influenced by a passing interstellar object. After all, if such coupling were real, it would imply vulnerability on a planetary scale. The more curious minds dug, the more inconsistencies they found. A research group in Kyoto noticed that several global magnetometer readings had been backdated by exactly 90 minutes. The change wasn't random. It aligned the data with the absence of the resonance event. By shifting the clock, the anomaly vanished from view. The same team later discovered that NASA's raw heliocentric positional data for 3I Atlas had been updated post-event, subtly adjusting its trajectory to appear offset from Earth's magnetic footprint by a few arc minutes. It was a small change, but enough to break the geometric correlation that had first raised eyebrows. In effect, the narrative was being rewritten in real time. Those who noticed began documenting the changes, taking screenshots, timestamping revisions, and sharing archives privately. A digital underground formed, scientists, amateurs, and data archivists bound not by conspiracy but by curiosity. They called themselves the Resonant Archive. Their findings were chilling. One recovered dataset from a Chilean ALF station contained a buried note in the metadata. Signal removed due to anomaly cross-correlation, classified under Project Helios. No one had ever heard of Project Helios. Searches revealed nothing. But when the group cross-referenced other metadata tags from NOAA and ESA, they found similar labels: Helios A, Helios 9, Helios EM, each attached to files containing the same erased period of time. It wasn't just one dataset, it was a global operation. Meanwhile, public statements from major agencies grew increasingly vague. NASA's final comment was almost dismissive. Data inconsistencies observed during the period in question likely resulted from local interference patterns in the Schumann resonance network. ESA issued a nearly identical statement, word for word, to the Resonant Archive that mirrored phrasing was proof of coordination. Someone, somewhere, was ensuring the message remained uniform. Then came the revelation no one expected. A Swiss atmospheric physicist leaked a set of unrevised Schumann logs from a private backup server. When those readings were compared against NOAA's current database, the raw version showed not only the known resonance spike, but 2 additional pulses occurring before and after the main event, separated by exactly 3.6 seconds each. That spacing matched the binary modulation pattern found earlier in Argentina's independent recordings. The same sequence of on-off intervals, the same mathematical precision. If the revisions had removed those pulses intentionally, it suggested an active attempt to conceal a repeating signal, a pattern that could not be explained by natural resonance. Why delete that? Perhaps because it implied intelligence, or at least structure. Word spread quickly within closed scientific circles. Some researchers began privately calling the deleted wave the third pulse. Others simply referred to it as the message. For those who had once laughed at speculation, the silence now felt orchestrated. No one could publicly mention the resonance event without risking professional backlash. Journal submissions were quietly rejected. Emails went unanswered. Even conference proposals touching on the subject were flagged for irrelevance. One physicist from Kyoto University wrote in his personal notes, later leaked anonymously, "They are rewriting physics by omission. Every line deleted makes the universe smaller." Weeks later, something even more suspicious happened. The Global ALF Network, a cooperative of universities and research stations sharing real-time resonance data, suddenly experienced a worldwide outage. For 3 days, no Schumann data was accessible from any public portal. When service returned, a new disclaimer appeared. Due to data integrity concerns, certain frequency bands may be unavailable until further notice. Those frequency bands, coincidentally, were the same ones that had spiked during the 3i Atlas event. Behind the scenes, whispers of institutional fear began to leak out. One insider at the European Space Operations Centre allegedly told a journalist off record, "It's not that we don't know what happened, it's that we're afraid of what it suggests." For a brief moment, the idea of planetary resonance coupling, once dismissed as pseudoscience, became taboo, not because it was false, but because it might be true. To admit that a passing interstellar object could influence Earth's electromagnetic skeleton would mean rewriting our understanding of space weather physics, planetary defense, even consciousness studies. It would mean admitting that the cosmos itself could speak in frequencies we've only just begun to hear. The suppression then wasn't just about hiding data, it was about preserving a worldview. Still, the truth has a way of lingering in the margins. Among the files the Resonant Archive preserved was an image of the unfiltered resonance waveform. When converted to spectrogram format, the pattern revealed something hauntingly elegant. 3 peaks forming a geometric ratio 1.618 to 0.618, the golden ratio. Natural harmonics rarely fall into that alignment by accident. It was symmetry woven into signal, a mathematical fingerprint of resonance, both natural and universal. Perhaps that was what frightened them most. Not that 3i Atlas made Earth ring like a bell, but that the bells sang in the language of order, a language humanity might not yet be ready to translate. Speculative pathways, theories beyond standard physics. By the time official channels went silent, independent minds were already charting new territory. The unexplained resonance spikes, vanishing datasets, and silent institutional revisions had done something unintended. They ignited a renaissance of speculation. Scientists, engineers, and rogue theorists began connecting the dots between what was observed and what might lie beyond conventional physics. The question was no longer if something extraordinary had happened when 3i Atlas crossed Earth's magnetic footprint, but what kind of force could make a planet sing? One of the earliest and most intriguing theories came from a plasma physicist in Helsinki named Dr. Elina Rautavaara, who proposed the concept of heliomagnetic coupling harmonics. Her model suggested that 3i Atlas wasn't merely a drifting mass of rock and ice, but a temporary resonator, a charged body moving through the heliospheric current sheet, amplifying existing magnetic flux like a plucked string in the solar wind. The object's plasma sheath, she argued, could have synchronized momentarily with Earth's own field, setting up an electromagnetic bridge across millions of kilometers. In essence, 3i Atlas became a cosmic tuning fork. Rautavaara's model received quiet interest, even from researchers unwilling to go public. Her calculations demonstrated that, under certain geometries, an interstellar object's induced current could match the resonant frequency of a planetary magnetosphere without direct contact. The energy involved would be negligible by cosmic standards, but enough to trigger measurable ALF, extremely low frequency amplifications, precisely what the Schumann resonance monitors had recorded, yet this was still within the borders of physics. Extreme, yes, but plausible. Others went further. A research collective from Prague, operating under the pseudonym Project Okeanos, proposed that the resonance was evidence of non-local field entanglement, a term borrowed from quantum theory but scaled to astrophysical proportions. According to their hypothesis, 3i Atlas could have interacted not by transferring energy through space, but through an instantaneous coupling between magnetic systems already entangled at a deeper level of the universe's structure. In their papers, and distributed privately, among peers they described the Sun's magnetic field as a central node in a vast web of connected magnetic entities, with each planet, moon, and interstellar object acting as oscillators within that field. When 2 nodes aligned perfectly in phase, even briefly, a harmonic bridge could form. The result? An instantaneous exchange of electromagnetic coherence, experienced on Earth as a Schumann resonance spike. If true, it would mean the universe isn't a void filled with isolated bodies. It's a resonant lattice where everything vibrates in silent dialogue. Skeptics called it mysticism wearing a lab coat, but the Prague team pointed out that the mathematical signatures of the anomaly, the harmonic ratios, the coherence duration, the global synchronicity fit perfectly with their theoretical model of field entanglement through magnetic alignment, and they weren't the only ones to notice. In Switzerland, an astrophysicist named Dr. Livia Koenig began exploring parallels between the resonance event and frequency synchronization in biological systems. She compared the Schumann anomaly to neural entrainment, the process by which brain waves lock onto external rhythms. Koenig suggested that Earth's field as a dynamic electromagnetic organism might behave similarly, capable of entraining with external frequencies under specific resonance conditions. She coined a provocative term for the process: planetary coherence response. In her view, 3I Atlas wasn't a catalyst in the traditional sense. It was a signal, and Earth was the receiver. Koenig's paper was never published. Colleagues advised against it, fearing association with what critics called consciousness cosmology. Yet in private interviews, she spoke bluntly. If human consciousness can entrain to frequencies in the 7-8 Hz range, and Earth's cavity resonates at the same frequency, then the planet itself is part of a larger feedback network. Electromagnetic, yes, but perhaps also informational. Maybe what happened wasn't an impact, but communication. Her words rippled through online physics forums, sparking heated debate. Could electromagnetic resonance carry information, not just energy, across astronomical scales? That question drew in another camp, researchers of wave information theory. Drawing from the work of physicists like David Bohm and Rupert Sheldrake, they speculated that magnetic fields could act as carriers of structured information, not binary code, but analog forms. Under this view, 3I Atlas might have transmitted a pattern encoded in its plasma oscillations, one that Earth's field briefly decoded as resonance. A handful of theorists even compared the harmonic ratios of the anomaly to mathematical constants like the Golden ratio and Fibonacci sequences. The symmetry was uncanny, too precise for chance, too elegant for noise. It echoed the geometry found in atomic lattices, DNA helices, and spiral galaxies. Was it a coincidence that the universe's most recurring number appeared in the electromagnetic voice of a planet struck by interstellar resonance? Or was it evidence that the same underlying mathematics governed both the microcosm and the macrocosm, the living and the celestial? Still others took a darker view. A faction of astrophysicists and defense analysts began whispering about directed resonance technology, the idea that an object could be deliberately engineered to trigger planetary frequencies for observation or manipulation. This theory emerged after the leak of internal documents referencing Project Helios, the mysterious classification label seen in the suppressed datasets. If such a project existed, it implied that some organizations already suspected, or perhaps understood, the principles of interplanetary magnetic coupling. The resonance event in that context could have been a test, an experiment conducted on a planetary scale. But who, or what, would have conducted it? Some suggested a terrestrial source, a classified Earth-based transmitter or satellite system operating at ELF frequencies. Others believed the object itself might have been artificial, an autonomous probe using field resonance as a means of interstellar communication or navigation. After all, interstellar space is hostile to radio. Electromagnetic resonance, on the other hand, can travel indefinitely through the plasma web of the heliosphere. If an advanced civilization wished to communicate across the stars, they might not use light or radio at all. They might use magnetic harmonics, embedding data in the natural resonant frequencies of planetary fields. One speculative essay circulated in encrypted networks under the pseudonym Nostos. It argued that 3I Atlas could be part of a vast, ancient network of resonant objects, fragments seeded across galaxies to interact with magnetic worlds and awaken specific responses when conditions align. The essay's title was chillingly simple: The Bells of Creation. Even those who dismissed it as poetic couldn't ignore how well it fit the pattern. Yet, there were alternative theories, ones that stayed grounded but no less unsettling. Some geophysicists explored the idea that 3I Atlas might have triggered quantum magnetodynamic resonance, a process where low-energy plasma disturbances resonate with quantum vacuum fluctuations, briefly amplifying background electromagnetic noise into measurable signals. In this interpretation, the event was a glimpse into the hidden quantum structure of space itself, a fleeting intersection where matter, magnetism, and vacuum entanglement sang the same note. Others returned to the notion of cosmic archetypes, repeating resonance signatures embedded in the geometry of the universe. They proposed that interstellar visitors like 3I Atlas were simply following paths defined by harmonic nodes, invisible corridors of stable resonance connecting star systems like a musical grid. If so, the object's alignment with Earth wasn't coincidence. It was inevitable, and if it happened once, it could happen again. In a recorded interview, later removed from YouTube, one unnamed physicist described his lingering unease. "We treat interstellar objects as inert wanderers, but what if they're instruments? What if each one that enters the solar system activates a chord, and together they compose a song we're too small to hear?" His words lingered like an echo of the event itself. Even more astonishing were reports from amateur radio astronomers who detected faint ELF pulses weeks after 3I Atlas had moved beyond Earth's longitude. The pulses occurred at diminishing intervals as if the resonance was fading, but not gone. One observer described it as a heartbeat echoing through the void. To explain this persistence, theorists invoked resonant memory, the idea that once a planetary magnetic field is tuned to a frequency, it can continue oscillating in that mode until reabsorbed by solar noise, like a struck bell still vibrating long after the hammer is gone. That concept took on a mythic dimension among followers of fringe astrophysics. They began calling the anomaly the memory of the bell. Whether the theories were physical, quantum, or metaphysical, they shared one haunting theme, the sense that the cosmos was not silent, but alive with hidden harmonies. 3I Atlas, in crossing Earth's magnetic footprint, had not simply disturbed our field. It had reminded us that the universe is a continuum of energy, geometry, and perhaps intention. Somewhere between science and mysticism, between plasma physics and cosmic consciousness, a new field of inquiry was born, one that dared to ask not just how the universe moves, but why it sings. And as data continued to fade and official statements grew colder, one quiet realization spread through those who studied the event. Maybe 3I Atlas didn't just pass by. Maybe it played us, and the song is still echoing. Opposing interpretations see coincidence or correlation. For every voice that called the 3I Atlas resonance event a breakthrough in planetary physics, there were others, louder, credentialed, and determined, who called it nothing more than a beautifully timed coincidence. They argued that the world was hungry for mystery, not evidence. That the scientists, enthusiasts, and theorists tracing hidden geometries between the stars were seeing patterns where none existed. And yet, even the skeptics could not deny one uncomfortable truth: the data had happened. Still, they insisted the explanation was simpler, boringly terrestrial. The first rebuttal came from NASA's Heliophysics division, which released a short, measured statement. It read, "Schumann resonance variations are common, caused primarily by global lightning activity, ionospheric temperature changes, and local electromagnetic interference. The timing overlap with 3I Atlas's heliocentric crossing is purely coincidental." Within hours, other agencies echoed the same language: ESA, JAXA, NOAA, all emphasizing coincidence. But their unity in tone only fueled suspicion. Why were they reading from the same script? Independent researchers noticed that the same press template had been circulated through a shared mailing list for interagency communications. The implication wasn't that they were lying, but that the official line had been pre-coordinated long before the investigations were complete. Behind the calm dismissal, the debates turned fierce. Dr. Henry Klein, an astrophysicist from Caltech known for his blunt empiricism, became the unofficial voice of the skeptics. "Everything about this event can be explained by noise," he told Scientific American. "The human brain excels at connecting dots. It's what gave us constellations out of chaos." But space doesn't operate on our mythology. He pointed out that Earth's Schumann resonance naturally fluctuates by up to 0.5 Hz per day, often spiking due to global lightning clusters unseen by most sensors. A brief uptick in frequency, therefore, wasn't abnormal. It was routine atmospheric chatter, amplified by coincidence. But others countered that argument quickly. If lightning were responsible, why did the Schumann monitors record identical harmonic structures across every continent? Why did magnetometers, seismographs, and auroral sensors, devices unrelated to atmospheric electricity, register matching patterns? The skeptics doubled down. They cited instrument cross-coupling, a known effect in distributed systems where electronic interference creates false synchronization across data networks. In this theory, a software glitch, not the cosmos, had linked the readings. It sounded plausible until analysts reminded them that several of the observatories in question weren't even connected to the internet at the time of the event. Klein dismissed that too. "Coincidences don't need conspiracies," he said during an online panel. "They just need timing." His stance appealed to logic, but not to the evidence. And slowly, cracks began to show in the narrative of coincidence. The Nature Geoscience Review Board privately circulated a draft paper titled Global Schumann Anomaly of 2045 Patterns and Probabilities. The authors, spanning institutions from Poland, India, and Japan, performed statistical modeling of the event's probability of natural occurrence. Their conclusions stunned even themselves. The odds of such globally synchronized resonance appearing without a driving factor were less than 1 in 73 million. That number was quietly omitted from the final publication. Still, the skeptics persisted. The Royal Astronomical Society hosted a debate under the title Resonance or Randomness, where veteran solar physicist Dr. Elise Marenko took the stage to argue that the anomaly was psychological. "When data is ambiguous," she said, "people project significance. We saw it with Tabby's star, with Oumuamua, and now with 3I Atlas. The pattern is not cosmic, it's human." Her opponent, a geophysicist named Dr. Kenji Arai, disagreed sharply. He presented time-stamped overlays of Schumann resonance data with 3I Atlas's trajectory and pointed to the perfect symmetry in phase timing. "You can call it coincidence," he said, "but when coincidence repeats with mathematical precision, the term loses meaning." The audience was split down the middle, and so was science itself. For every cautious skeptic citing probability, a quiet believer emerged with new data. Unfiltered spectrograms, satellite readings, even ionospheric temperature logs showing microheating that coincided exactly with the resonance, but mainstream journals refused to touch it. Editors invoked methodological concerns. One astrophysicist who submitted a correlation study said his manuscript was returned without review, accompanied only by a single sentence: "This topic is not scientifically actionable." In academic language, that meant don't touch it, and yet the idea refused to die. Among the public, the event became mythic, a battle between orthodoxy and open inquiry. Coincidence or correlation became the question whispered across online physics boards, podcasts, and late-night talk shows. Some skeptics, like Klein, grew more combative, warning that pseudo-astronomy was infecting serious research. But others took a softer tone. They conceded that while the alignment of events was striking, the mechanism remained unproven. Without a repeat occurrence, they said, the anomaly would forever remain an unsolved curiosity. Then, quietly, a few of the early skeptics began to shift. Months later, ESA's Space Weather Division released a technical note titled Unexpected Coherence in ALF Range During Interstellar Transit. The KITE's note didn't name 3I Atlas directly, but acknowledged global-scale phase synchronization during an unspecified external electromagnetic event. It was bureaucratic language for something the scientific establishment wasn't ready to explain, and it opened a crack in the wall. Even Klein, the staunch empiricist, admitted in a later interview, "I can't say it's impossible, just improbable." But physics has a history of turning improbabilities into revolutions. What made this case different was that both sides were, in some way, correct. The skeptics were right that natural Schumann fluctuations exist and that human perception leans toward pattern seeking. But the data analysts were also right. The synchronization, the global symmetry, and the timing precision were statistically absurd. The argument, then, wasn't about facts. It was about what those facts meant. To skeptics, 3I Atlas's crossing was a perfect storm of random alignments, a quiet sun, stable magnetosphere, and coincidental shifts in terrestrial resonance that happened to coincide with the interstellar visitor's path. To believers, it was the first measurable evidence that Earth's electromagnetic field is part of a grander cosmic circuit, a living, resonant system responding to the geometry of the heavens. Some proposed a middle ground. Dr. Ada Lorenzo, an atmospheric physicist from Italy, argued that both could be true. Coincidence can still reveal structure, she wrote. If 3I Atlas amplified an existing resonance, it didn't cause it, it participated in it. The event might be a window into how small fluctuations align into large-scale harmony. Her framing, neither denial nor mysticism, caught on. Participatory coincidence became a phrase used in academic blogs to describe phenomena that straddle causation and synchronicity. Still, for every mind-seeking nuance, another sought certainty. The most dogmatic skeptics accused independent researchers of weaponizing ambiguity. They insisted the resonance was either caused by local lightning or electronic crosstalk, yet none could explain why the Earth's magnetic and atmospheric readings behaved like a single global instrument. The believers, on the other hand, sometimes drifted too far. Some began claiming the resonance carried messages, patterns, or encoded frequencies of intelligence. Others tied it to prophecies or lost civilizations, muddying the discussion with pseudoscience and mysticism. Between these extremes, a quiet group of data-driven investigators persisted, obsessed not with ideology, but with truth. They pointed to an irony few noticed. Skeptics themselves had confirmed that the event was measurable. In denying its cosmic cause, they had acknowledged its terrestrial effect. Whether coincidence or correlation, something had made Earth's resonance shift, and that something, known or unknown, had happened only once in recorded history, when an interstellar body crossed precisely through the geometry of our planet's magnetic mirror point. Perhaps the real divide wasn't scientific at all, but psychological. One side feared mystery, the other feared meaning. The skeptics held to comfort, the universe as random, indifferent, cold. The believers held to wonder, the universe as ordered, resonant, aware, and both stared at the same dataset, seeing opposite reflections. Years later, a journalist asked Dr. Klein whether he still thought it was all coincidence. He paused, then smiled faintly. "Coincidence, yes," he said. "But that's the funny thing about the universe. Sometimes it's too good at them, because in the end, no amount of denial or belief could erase the evidence that lingered. The harmonic traces, the statistical impossibility, the unanswered silence in the official record, and as more interstellar objects drift toward the inner solar system, each crossing a different alignment of magnetic geometry, the same question waits in the background, patient and electric. When it happens again, will we still call it coincidence? Or will we finally admit the pattern has been playing all along? The deeper implication, the universe, listens back. Long after the debate over coincidence and correlation faded, one truth refused to die. The planet had responded. Instruments had recorded it, witnesses had seen it, and the silence that followed had only deepened the unease. Something beyond explanation had passed through our part of the cosmos. Something that struck not with force, but with resonance. And the deeper scientists looked, the more they began to sense that this might not have been an isolated event, but a glimpse of how the universe itself works. If 3I Atlas truly tuned Earth's electromagnetic field, the implications went beyond physics. It meant that planetary magnetospheres, once seen as static shields, might actually behave like sensory organs within a larger cosmic body. In this framework, Earth was no longer a rock wrapped in a magnetic field, but a living circuit in a galactic web, capable of detecting, reacting to, and even echoing distant cosmic disturbances. That idea was radical, yet ancient. Long before magnetometers or satellites, ancient cultures had whispered of the breathing Earth. They described it as pulsing with invisible rhythms that governed weather, fertility, and fate. Scholars dismissed those myths as poetic. But what if the ancients had simply felt intuitively what modern instruments had only just begun to detect? The faint hum of a planet attuned to the cosmos. Some physicists began to view the resonance event not as an anomaly, but as evidence of a participatory universe, a concept once proposed by John Archibald Wheeler, who suggested that consciousness and matter are entwined in a feedback loop, where observation and existence are two sides of the same act. What if the same principle applied at a planetary scale? What if celestial objects, planets, comets, interstellar travelers, are not just passive participants in a clockwork universe, but nodes in a system that hears itself? In the weeks after the resonance, a small interdisciplinary group formed quietly under the name the Listening Project. Its members were physicists, philosophers, and signal analysts who believed 3I Atlas had revealed something extraordinary, that space might not be silent at all, merely tuned to frequencies we seldom notice. Their theory was simple, yet profound. When an interstellar object crosses a planetary field, it doesn't just perturb it, it causes feedback, a kind of echo, where the planet's field vibrates in sympathy and the cosmos, in turn, receives that vibration back. A universal call and response. To test this, they analyzed magnetometer records not from Earth, but from Mars and Venus during 3I Atlas's transit. To their astonishment, faint harmonic traces appeared in both datasets, offset by propagation time through the solar plasma. The frequencies were weaker, but the pattern was unmistakable. A ripple passing not through space, but through a shared electromagnetic medium that bound the planets together like instruments in the same orchestra. If Earth had rung like a bell, the rest of the solar system had listened. The implications were staggering. It meant resonance was not a local event, but a communication, one that traveled through the heliospheric web, linking planets, moons, and even interstellar objects through frequency coupling. The cosmos, in other words, might be listening to itself. This concept, dubbed reciprocal resonance theory, challenged the very foundation of astrophysics. In standard models, gravity rules and electromagnetic fields are secondary. But if magnetic resonance truly linked celestial bodies, then energy, information, and even meaning might flow through channels science had long ignored. The universe, according to this view, wasn't a collection of inert objects obeying blind laws. It was a dynamic conversation between magnetic fields, plasma flows, and possibly even consciousness itself. It was, as one researcher described it, a symphony of geometry, The Listening Project's internal notes revealed startling patterns. Every known interstellar object observed since 2017 from One-Eye Oumuamua to Three-Eye Atlas had coincided with subtle, measurable deviations in Earth's ELF spectrum. The frequencies were too weak to draw conclusions, but consistent enough to form a trend. If the data held, it meant interstellar crossings weren't isolated flukes. They were part of a repeating signal, a recurring punctuation mark in the cosmic sentence. And yet, the more they studied the pattern, the more it resembled something deliberate. Not intelligent, perhaps, but structured. Each interstellar event seemed to fall on intervals corresponding to the harmonic nodes of the solar magnetic cycle, as if timed to coincide with natural resonance points. To some, that suggested design. To others, inevitability, a kind of cosmic rhythm that objects unconsciously obeyed. Still, one implication haunted everyone who studied the data. If the universe can transmit resonance across vast distances, then we might not just be listeners, we might also be transmitters. Every pulse of our planet's field, every radio emission, every flicker of artificial frequency we generate could be rippling through the same plasma network, echoing outward into the dark where something, or someone, might one day hear it. In a private meeting held in Geneva, one of the project's senior researchers, Dr. Livia Koenig, summarized it in words that chilled the room. If resonance is truly reciprocal, then the question isn't whether the universe can hear us. It's whether it already has. Her statement lingered like a note in air. It forced the scientist to ask questions that crossed the line between physics and metaphysics. What if the universe doesn't simply expand? What if it responds? What if every fluctuation in the electromagnetic sea, every planetary hum and stellar pulse, is part of a vast feedback system maintaining equilibrium, a cosmic nervous system regulating itself through soundless communication? The ancient mystics might have called it the music of the spheres. Physicists now were beginning to call it the magnetospheric network. But there was a more intimate implication still, one that unsettled even those who loved the mystery. If the universe listens, then observation is not passive. Every time a planet vibrates, a star flares, or a human switches on a transmitter, a signal goes out, and something answers, however faintly. This reciprocity meant that causality might not be one way. What happens here might not just echo outward, it might reshape the patterns that return. It was a feedback loop between creation and perception. To test whether such feedback could be real, the Listening Project ran a simulation using decades of solar and planetary magnetic data. The results were unnerving. Certain frequencies emitted from Earth, particularly in the 7-8 Hz range, appeared to modulate solar wind density weeks later. Statistically small but beyond random chance. It was as if the planet's hum could subtly influence the solar plasma that, in turn, shapes its magnetic field, a circular conversation between Earth and Sun, mediated through space itself. When they presented the findings to a closed audience of physicists, the reaction was polarized. Some were enthralled, others furious. "Correlation isn't causation," one shouted. "The sun doesn't listen to us." But others weren't so sure, because when the simulation was extended backward through time, the same pattern reappeared, faint but persistent. During key moments in Earth's magnetic history, the Carrington event of 1859, the geomagnetic anomaly of 1958, and even the minor Schumann surges during the passage of Oumuamua. Each time, a call and an echo. If those alignments were real, then the Three-Eye Atlas event wasn't just a physical resonance, it was an act of cosmic memory. A brief moment when the universe remembered its own structure and whispered it back to itself through the language of fields. The theory was poetic, perhaps too poetic for science, but even skeptics admitted its strange coherence, Because if the universe is bound together not only by gravity but by resonance, then it is not inert, it is responsive. Every motion, every signal, every alignment becomes both an observation and an answer. In this light, 3i Atlas wasn't an intruder, but a participant, a messenger passing through a system that heard its arrival, echoed its vibration, and resumed its silence only after the song had been played. And that silence, some argued, was not emptiness. It was listening. For months afterward, ultra-low frequency stations continued to record subtle fluctuations that some called aftertones, faint harmonic trails that pulsed across the ionosphere like fading memory. The data didn't fit any known solar or atmospheric model. It was as though the planet itself was quietly replaying the resonance, remembering what it had heard. No one could prove it. No one could disprove it. But once you heard the idea, it was impossible to unhear it, that maybe we are not the only observers in the universe. Maybe the universe observes us in return. And if that's true, then 3i Atlas was not just an object crossing space. It was a question flung into the void, and Earth's ringing reply was the answer. A cosmic conversation, brief and fragile, yet impossibly vast. Somewhere out there, in the charged silence between stars, that vibration still travels, faint, expanding, eternal, and perhaps, when another interstellar traveler passes through the heliospheric web, the same song will rise again, a whisper between worlds, a reminder written not in language but in frequency, that in the grand stillness of the cosmos, nothing truly moves alone.